Just say, hey, you're listening to Cult of Reason. Just say something like that.
I can't do it right now.
I believe virtually everything I read, and I think that is what makes me more of a selective human than someone who doesn't believe anything.
Cult of Reason.
We're all monkeys.
Apes don't read philosophy.
Yes, they do, Otto. They just don't understand it.
Cult of Reason.
The only true wisdom consists in knowing that you know nothing. That's us, dude.
I anticipate a deeply religious experience.
An interesting way to open up a conversation.
Heyo, welcome to Cult of Reason. This is my first podcast. Thanks for listening. And yes, I think heyo is going to be my lead-in for every podcast. On this first episode, I'm talking with Vaibhav, Diwadkar, and Otto, Musik, who are two neuroscientists at Wayne State University. And we're talking about a guy named Wim Hof, or the Iceman. So I'll tell you more about my interview guests and Wim Hof in a second. But first, just a couple technical disclaimers. The voice levels are all over the place. Part of the problem is I only had one mic, and I didn't really plan on me talking to two interview guests. So this mic isn't really built for that very well. On top of that, the speaking styles for everybody were different, and Otto was a lot louder than Vaibhav. I was closer to the mic than they were, so that didn't help either. And then finally, there's this thumping noise throughout the recording that I guess somebody was tapping on the table and I didn't notice, but the mic is so sensitive that it's picking it up. It's kind of obnoxious, so sorry about that too, but those are two easy things that I'll fix for the next one. So the best thing to do to get background on Wim Hof is to watch the Vice documentary. It's on YouTube, it's free, it's about 45 minutes. I also have a link to it on my website, cultofreason.life, and it's a great documentary, really interesting. So Wim Hof is known for feats of cold tolerance. So for example, longest amount of time in an ice bath, that kind of thing. And he's got 26 world records related to that. And he says he accomplishes this through a method he developed that involves repetitive cold exposure, a specific breathing technique, and meditation. What's controversial about Wim Hof is that he says the method not only allows him to withstand the cold, but that he can use it to access and control his autonomic nervous system. And that's controversial because the current scientific consensus is that that part of your brain is not accessible to your conscious control. So it happens in the background. You can't control it. Not only that, but he says that he can also affect his innate immune system. He can control levels of inflammation in his body, and that his method will be useful for treating depression, autoimmune diseases, Crohn's disease, and even cancer. So because of my background with med school, and I did a PhD in neurodevelopment and just an overall very traditional science background, I tend to be very skeptical when I hear large claims like that. But I'm also open-minded, and I think a lot of things, even though they seem counterintuitive, could potentially be real. Just you need to study them systematically and scientifically like anything else to actually prove that. So what is interesting about Wim Hof is that he doesn't just make these claims and just expect everyone to take his word for it. He's been aggressive about having scientific studies done on him to try and figure out what's going on physiologically and otherwise when he does his method that allows him to do some of these things. The documentary goes into some of those studies, but basically he's proven that he can take a group of regular people, train them for 4 days, and through using his method, they were able to measure significant differences in something called epinephrine, which is part of your autonomic nervous system, and showed that for the first time, these subjects could voluntarily increase the amount of this epinephrine. They also showed that pro-inflammatory cytokines were lower and anti-inflammatory cytokines were higher in these test subjects. And these findings were published in Proceedings of National Academy of Sciences, which is a very legit journal, and it caused some waves in the scientific community because it was the first time it had been demonstrated that you could consciously control aspects of your autonomic nervous system. So I don't remember where, but one day I read that Wim Hof was at Wayne State, and that's right by me in Detroit, and he was in the neuroscience department there, which is where I did my graduate school, and that some researchers had a suit that could pump cold water through, and they were doing some imaging studies on him to try and figure out more of what's going on when he's using this Wim Hof method. So I looked those guys up and sent them an email, and that, of course, was Otto and Vaibhav, and they were nice enough to agree to come talk to me, and that's how the first podcast was set up. So Vaibhav is in the Department of Psychiatry and Behavioral Neurosciences. Otto is in the Department of Pediatrics, Radiology, and Neurology. They're both brain imaging experts and very successful researchers with tons of publications and in various different fields of interest. The area they share a common interest in is the neurosignaling pathways involved in thermogenesis, or how your body maintains its core body temperature. And so that brought them together for their experiments with Wim Hof. They're also just great guys and super fun to talk to. I had a blast, and when we first got started, we got off on all kinds of tangents talking about life and politics and Trump, and kind of had to force ourselves to get back to the topic at hand with the Wim Hof stuff. I just cut all that stuff out because the conversation is a little hard to follow, I realized, listening back to it. So just to simplify things, I just only kept in the Wim Hof stuff. So without any further ado, here's my conversation with Vaibhav Diwadkar and Otto Musik about the science behind the Wim Hof method. Stuff, and we should try and talk a little bit about the
price of hair.
Yeah. So
are you doing the Wim Hof method?
No. So let me just give a little bit of background. So I read about you guys, all your publications. It was not possible. You guys have been machines publishing a lot of stuff out there. You're both imaging experts. I think you have, Otto, more of an epilepsy focus traditionally.
I do PET and epilepsy.
And you're more of a psychiatric. And then at some point you guys came together with thermogenesis and mapping out the neuronal pathways, architecture of what, how thermogenesis works. And I saw your paper on the brown fat with healthy volunteers.
You are well read, my friend.
Well, I try to do my homework, to have some idea. And so I can see how you guys came together and how this Wim Hof thing would be interesting to you guys. So how did you get involved with Wim Hof?
Let me just say, and then I'll let you talk. Actually, it's really interesting because it's always in science, you start with something in a completely different direction. So in that case, what you read, brown fat, and the brown fat, for reasons that NIH was interested in people losing weight, and if you activate brown fat, then people lose weight and so on. And so we started with that, and this cold exposure was kind of an afterthought just to release norepinephrine. Mm-hmm. And if you would like to release norepinephrine in a person, you can use drugs, but it turned out that the most effective method is just to make people cold. That's actually, there are a lot of literature about it. Mm-hmm. So, and it actually is, was very, very, very easy, just moved outside the balcony. So we did this, but it was really kind of as a mean to a purpose in order to brown fat. Mm-hmm. And then somebody suggested, well, let's look at the brain when we do cold, if the central nervous system has anything to do with brown fat. So at this point, there was no big neuroscience. It was kind of more, well, let's see what we get. And then things we saw really interesting, which now go way beyond with brown fat. Brown fat is now really in the background.
Well, that was the conclusion of your paper, it seemed like. It was very minimal contribution.
It's 10 kilocalories a day, even if you have 100 grams. A banana has 80 kilocalories. Mm-hmm. So don't eat a banana and go ahead.
Right. To some extent, this has actually been also validated in scanning Wim Hof. because the title of our paper...
Well, I want to get into that. We'll set that up in a second. So
anyway, but actually, Vaibhav can tell you now. So basically, that was kind of my opening statement, how science works, that you work in one direction and actually opens up. And how it actually goes, and we can tell you then about cannabinoids and where we're going, it's a completely different direction.
My entry was also, fortuitous is not the right word, but it was not planned. So most of my work has been in psychiatric illness, and I'm trained as a cognitive neuroscientist. So the goal is to try and understand how the brain implements cognitive function, language, memory, attention, and so on. But I actually had a colleague at Wayne State who, for many years, the only thing he studied, of all things, was menopause. And he studied it using electrophysiology and other peripheral techniques. But nobody had ever done neuroimaging in it. Now, not that just because somebody hasn't done neuroimaging in something, you should do neuroimaging in something. But nevertheless, menopause is a very unique, endogenously occurring thermal regulatory event. And nobody had ever actually looked at its quote-unquote neuronal origins. And so that's how I got involved in this question. And so we published one paper on that. But the interesting thing is that from my perspective, I was not so much interested in menopause per se. For me, menopause was a model of a particularly interesting event that is happening in the body, which may have particular correlates in the brain. And so that's how I got interested in the question of menopause. And at some point, Otto and I, we've known each other for a long time, but we intersected on this question 2.5 years ago. But we both came at it from different points. But our fundamental interest was the same thing. What is happening in the brain when the body is either experiencing, as in the case of menopause, a natural event, or is subjected to an experimentally controlled.
And you guys found basically the similar thing happens. And not your study was more cold exposure, but the literature
Mine was
suggests
cold exposure. It was obviously hot flashes.
Yeah,
right?
And the literature is consistent with whatever mechanism happens. It's similar with menopause, an internally generated versus an externally.
In terms of the brain regions that are implicated, yes.
Yeah,
it's the same. Now,
so essentially, to call it really is the insula. The insula is the most important interoceptive part of the thing. That's actually where everything comes together. You can go through the anatomy, but if you experience cold, it goes through the effectors, spinal cord, lamina 1, brainstem, thalamus, and eventually comes to the anterior insula. And we can now make some hypothesis, but a lot of people believe that that's kind of the seat of when you feel like your body, yourself.
Right.
It's the seat because that's your visceral feeling of your body. So the insula, and that's actually what we then saw.
So I was trying to think before I met you guys of what your hypothesis was with Wim Hof, and you've shot down both of them now. So one, I don't think that you would have made the hypothesis that the type of neuronal signaling pathways you see would be different with him. So I don't think the study you just published together, you would expect to see different pathways. And with your results with the brown fat saying, it can't really create that much heat, it's kind of insignificant. By just walking up a flight of stairs, you can accomplish the same thing. So you're not necessarily thinking that what he can do is that related to an overabundance of brown fat.
No, definitely not. 100% not.
So
we know this for sure. Right. That's a given.
So
and actually, there are, sorry to interrupt you, but there was another paper 2 years ago from a Belgian group which did something similar, and they actually we got the same results. So it's a given. Brown fat has no role.
Okay. So what was your hypothesis? What was the idea? And then how did you actually get in contact with him and actually get the experiments going?
So in terms of hypotheses, I think our prediction was, why does he have this unusual ability to resist cold? Now, it's obviously the case that if you stand outside in the cold, there's a stimulus on your effectors, and you have these efferents go to the brain. The brain has to respond, and you have to take evasive action of some kind. Now, you can, of course, modulate your responses up to a certain point, and the presumption is that modulation has some cortical basis in its origin, which is a reasonable assumption. And so I think we expected that much of what he does is some kind of cortical modulation of autonomous systems.
So prefrontal cortex,
Prefrontal cortex.
The cognitive apparatus. Probably
Really?
Prefrontal, ventromedial, or anterior prefrontal.
So just make sure I understand what you're saying. So from what I've read about the studies I've done on them so far, it seems like the main influence on his thermogenesis has been epinephrine, and it's been related to his hyperventilation, pH changes, and as a way of indirectly modulating the autonomic nervous system through the pH and that type of thing. But you're saying you think there's something super.
No. Basically, this is okay. Let me just give you a 2-minute thing, and then we can discuss about the details, because I think this is important. This is exactly why does it work? And just kind of as an opening statement, I think that Wim Hof, tripped over something which might be very important, which for whatever reason people didn't pick up before. So what happens is that there is 3 parts. There's hyperventilation and breath retention, which activates your sympathetic nervous system. Right. So if you hyperventilate, you got hypocapnia, your CO2 goes down because you breathe too much CO2 out. So your pH value goes now up because you lose CO2 in the blood. Okay, now you have a very high pH value. Your body tries to get it back. So there's too much oxygen now in your blood. So you can retain your breath, and that's what he does. 90 seconds hyperventilation, 90 seconds breath retention, and he repeats it 3 times. What happens is that when you do this 3 times, you can do it yourself, you start feeling the tingling, which is from the hypocapnia. But what happens, your oxygen saturation in your blood goes to 70%, which is, usually you're dead when you have 70%. So your brainstem regions think you're suffocating. And that's the fight or flight reaction. You're suffocating, you are really now checked up. Norepinephrine, cortisol gets released. That's the first part. The second part, which is actually much more interesting, which I think is the contribution now, that you get stress-induced analgesia. When you hit it now with cold, what happens is the same reaction that when you run away from a tiger and you sprain your ankle, you don't feel the pain. Why don't you feel the pain? Because there are mechanisms in the brain which are in the periaqueductal gray, which releases cannabinoids and opioids in order to say, okay, forget the pain for now. But that's the thing. And then...
Can I just interrupt for 1 second? Is that related to danger-associated molecular pathways?
Well, the point is that it's naturally released. So it has you see, when you smoke marijuana or you take drugs, you give it, systemically to the whole body, which, might help you in one part of the body and screws you up in 20 other parts.
Right.
And when you do this recall, there is really a reason for it.
Right.
So it's all natural, the body does is natural, and increases these cannabinoids, opioids, and we can talk about this in very specific parts of the brain, which is essentially it's the ventral tegmental area and the raphe which then releases serotonin in the forebrain, and the dopamine in the ventral tegmental area, which the nucleus accompanies, and you get kind of psyched up, motivational drive. The point is that the point I'm trying to make is that he uses this hyperventilation to get the first sympathetic response, and you could do it by exercise. You can do it however you want. But
bungee jumping, anything that puts you into a state of
exactly. And then you escalate. This response, and when you escalate it, it's like spraining your ankle when you run away from a tiger. That releases now the cannabinoids and opioids in your periaqueducal gray, and that's actually what we saw. I don't know if you saw the paper. That's that. And that's
no, I didn't see the Wim Hof data.
Anyway, so this is actually the interesting part that. In short, and then I'll let Vaibhav talk, that in short, what he found out is a hack into your neural system to release endocannabinoids and endoopioids, So that's actually his contribution. And now, that's kind of, an observation. He just came up with that. So now you can actually have like hundreds of applications for it.
Right. So are the two just additive, the hypoxia and the cold exposure, or do they work in similar pathways?
That's actually interactive.
Well, this is not very clear. That's really so because people tried for a long time understand, for example, the runner's high. You run, and people say, okay, you need to run for 40 minutes. Why 40 minutes? Why not 5 minutes? Or why not 2 hours? So, and you shouldn't go go too fast, nor too slow. There's a certain thing, and you never know if it's going to happen. You never can guarantee you get high. And that's actually, I think, the same method that you get a certain sympathetic innovation, and then you get escalation, and then you head into the system. Mm-hmm. And that's why some people are addicted to running. They run,
But we suspect it's interactive because just doing so much of it isn't really going to get the effect that you want. In other words, just doing the breathing and the
cold exposure,
the meditation that he does, okay, that is insufficient. That the cold exposure actually has to interact with the state that the breathing puts.
Oh, really? Okay.
His brain,
gotcha,
and his body.
So they're more synergistic than additive. You're saying?
Exactly.
Well, you need to prime the system in order to have the second thing. So if you don't prime the system and you're just cold. There is nothing released in your brain. So you have to already be primed. You have to be in a stress situation.
Right.
And it really doesn't matter how you elicit the stress situation.
Right.
It could be an accident.
Right.
The thing, police car behind you.
Right.
Norepinephrine is cortisol, and then something happens, you don't feel the pain. That's
if somebody injects you with lipopolysaccharide when you're getting pulled over from a cop, you would also have a blunted response. Anything that jacks up your epinephrine and your adrenaline. So, what was your specific question you had that you guys wanted to study?
We try to understand how this works, why this works at all.
So, what makes you think that you could learn something different from him versus anybody that does these techniques or gets?
No, because he's an interesting model. He has demonstrative cold resilience, which is very unusual. Moreover, he's very accessible to us.
I still haven't learned that part yet. How did you get access to Wim Hof?
So we actually had a colleague of ours who was aware of his work, and we have several students who know of him. Mm-hmm. He's quite well known. I don't know if you knew of him before.
He's kind of a cult figure right now. I know.
So actually, when he gave his talk, when he visited us in February and he gave his talk, we had people who drove all the way from Lansing.
We had people. I was surprised.
It was standing room only.
I'm sure. Yeah.
I couldn't believe it. So you have like a supposed scientific talk, and then I met the usher from Joe Louis Arena. I was like really shocked.
Yeah.
Well, he said, I'm doing this. This works. This is great.
And there were people there who vouched for the fact that the Wim Hof method completely changed their situation. Who was the guy who had he had some immune disorder? What kind of immune disorder did he have?
In the movie or what?
No, at the talk.
Oh, yes.
Who vouched for the fact that before he started the Wim Hof method, he was a total wreck. And he started it, and it completely changed his life.
And actually, now if you put two and two together, the hypothesis is that you're releasing cannabinoids. We have medical marijuana discussion all the time.
Yeah.
This is actually a much better method because this is very, very, very focused in these areas when you want it. You see, the problem with cannabinoids is when you smoke it, they are very lipophilic. They go in all the body, in your fat tissue, so it never gets rid of it.
I want to get back to the implications for whether there's any practical role to this, because I have some questions about that.
There are millions of implications.
Well, but I'll play devil's advocate with that is Lisak still at Wayne State? Robert Lisak?
Yeah, Bob Lisak, yes.
I remember one thing.
He's emeritus now. So
is he?
Stepped down as
neurology, I think, right?
Neurology, yeah.
He stepped down. He's still working.
One thing that he said that I always remembered was the plura of anecdote is not data. And you get a bunch of people saying I had these amazing experiences. And that's great, but that's not necessarily data. That's not necessarily good evidence. And what got my interest with this Wim Hof stuff is I saw the Vice documentary, and I saw these huge claims of, this is going to treat Crohn's disease now, and this is how you control your innate immune system. And I think there's always a temptation to overreach, especially maybe somebody like Wim Hof, who's just a very excitable, charismatic guy who doesn't have a science background. He probably actually believes everything he says, but he also, I give him credit because he subjected himself to rigorous scientific studies, and so it's super interesting to go read and see what he's been doing. And then I saw that he came to Wayne State, and that's when I called you guys. So what was your actual study? What were you brought Wim Hof in, and what was what did you guys measure?
So Otto can give more details, but we essentially studied him with two different methods. The first method to study the periphery, which was
brown fat.
Brown fat. And the second method to study the center with functional MRI.
Study what?
The center, essentially the central nervous system.
Oh, okay.
The brain.
So with fMRI. And so that paradigm, the fMRI paradigm, is very closely related to the paper that we published last year in human brain mapping. And there, in both cases, he was subjected to controlled cold stress. In the case of PET, we were interested in quantifying the volume of activated brown fat, clavicular brown fat. The fMRI study was very interesting because it was conducted under two conditions. One was a passive condition, and the other was an active condition, which immediately followed doing his procedure.
So he was cold exposure with your suit, which is pretty cool, by the way. Did you guys come up with that, or is there multiple people using it?
Well, basically, there was one person in McAllister in Australia who kind of pioneered this. They kind of made it, but then we actually picked it up, and now it looks like a lot of other people went into it. So we are probably the second people who actually picked this up and kind of a little bit made it more sophisticated, but we were not the original.
But see, we needed it. We needed it because there have actually been only a handful of studies in humans on thermal regulatory defense. There's a massive literature in the rodent, okay? And that's where all this brown fat business came from.
Right.
But in humans, there's very little, and the reason is pretty obvious. It's just not that easy to do this kind of work in humans. There's a lot of work in humans looking at cold and heat pain, and so you're lying, your brain is being scanned, or electrophysiology is being done on you, and people apply a cold stimulus or heat stimulus to one of your effectors. But pain is not thermoregulatory defense, and so really this was born out of the interest that we talked about earlier, how we both came to the same question, and really a need for a paradigm that really served the purpose.
Right. You guys make a point of saying that the cold exposure through the suit is a non-noxious stimulus.
It's different than pain. I mean, it's to a certain extent so you can differentiate between pain and cold. Cold might not be very comfortable, but it's different than pain.
Okay, so you'd still say it was severe cold? Because it kind of sounded, when I read the paper, it sounded like, it's like a little bit of an annoying cold. I was wondering if Wim Hof got this thing on, and he was like, what is this? This is nothing.
So we tried to do non-shivering, so that you're cold but not shivered.
Okay.
That's the point.
I have another question about that. So Wim Hof, he's got whatever mechanism he has for thermogenesis, which I don't think we've necessarily cleared up yet, that you don't think is about brown fat.
No, and actually I tell you what I think, but just continue.
But there's a kinetic and a non-kinetic method of thermogenesis, right? Shivering is the kinetic, and then there's whatever else is going on, brown fat or otherwise. But why wouldn't he do both? Why wouldn't he still shiver?
Actually, he does that.
He does still shiver.
So this is actually the other point we found out, and it actually relates to a certain extent to what we see in regular people. So how you generate heat is when you get cold, is that your central muscle, your psoas, your erectus spinae starts shivering, but very subclinically. You don't feel that.
Oh, really? Okay.
So there is a calcium cycling, which is you so you shortcut because you always need to move calcium out from the vesicles in order to move your thing, to shiver, and it actually happens without really any, so you get the movement, but it's very, very subclinical. That's actually how it's done. And what was interesting is, and actually that's where it loops back to the breathing, because he makes a big deal of breathing, is that his intercostal muscle, so the muscle in between the ribs, they actually took up a lot of glucose, which we actually never saw before. Yeah. So he automatically, through his breathing, the muscle generates heat. Yeah. And which is actually even more beautiful, actually, the thing, is that it's close to the lung tissue, where blood goes in the lung tissue, it's distributed, a huge area in the arterioles. Yeah. So if you actually have a blanket over it, which is the intercostal muscle, and you heat that's actually the way to heat your blood, not in the carotid artery, where it's just, it's a flow. Right. So this breathing has two purposes. The first is to generate stress response. Right. The second is that you actually
kinetic energy
heat the blood.
Yeah.
And that's actually because the next question which you should be asking is, so how come, so the guy is going and, going to the Himalayas with, in shorts, how come he doesn't get frostbite?
Yeah, exactly.
And that actually we tried to figure out. Now I think that this is through this breathing, that he constantly heats the blood. And actually, it keeps the blood at a higher temperature level than would be normal. Eventually, he's going to get frostbite, but he's actually much more resistant to frostbite through this heating of the blood than normal.
So some kind of a tonic change that has happened.
But if your theory is correct, then why wouldn't we have evolved to use this simple trick in periods of cold? Why wouldn't we just, as babies, or without even thinking of it, just start hyperventilating when we're older?
Brown babies, that's a good question. We have brown fat. That answers your question. Once we get muscle, 3, 4, 5 years old, we lose the thing, and we have already the muscles. That's much better.
So it still seems like there'd be plenty of people dying before they were able to pass on their genes from hypothermia. That if there was an evolutionary solution as simple as just hyperventilating, that we would have learned to do that. You know what I mean?
But you could argue we've evolved to avoid situations where we were hypothermic.
And that's actually exactly the point. Why do you think you feel cold? To feel cold, why do you have affective system? So you have an autonomic
to get out of that noxious environment.
To do an action, to make fire, to go inside. That's actually why you feel the cold. Otherwise, why do we need to feel cold if there is no consequence?
Our brains have evolved to actually change circumstances which allow us to successfully evade cold.
And
that's why the rodent model for thermal regulatory defense has relatively poor generalizability for humans.
It's for a lot of reasons, because the surface is huge regarding to volume. I mean, for a 20-gram mouse, the surface is huge, to the inside. So they need a completely different mechanism to keep warm. But I think what you make a really good point is that you have this tripart. You have the autonomic system. Your body does what it does, vasoconstriction, releasing brown fat, whatever. Then you have the affective part, which is the limbic system, paralimbic system, insula, amygdala, orbitofrontal cortex. Actually, the insula is the most important, which gives you the feelings of cold, pain, hunger, and the only purpose of these feelings is to generate an action, because it's really difficult. How would you else generate an action or motivate an action?
If you had no interoception, you put your hand in a pot of boiling water, you're scalded.
Right.
And your body does what it does.
If you have no thirst sensors, you die.
Or hunger. Why do you hunger? Because it tells you your energy reserves are down. Please eat. And that's actually the same thing. You are cold. You make fire. You go inside. You put a sweat on. This is exactly what it is. So you help the autonomic system a lot by giving an action. And because the humans were actually really good in doing the actions, you probably don't need to be so picky about your autonomic thing, starting breathing and things.
Yeah.
I mean, you could.
So if I understand you right, you're saying brown fat isn't relevant, and you say that the whole Wim Hof method is mainly a result of the hyperventilation and the increase in kinetic.
My point is that the Wim Hof method is release of opioids and cannabinoids from your periaqueductal grade. That's the method. The thing is just kind of preparation, because you need to prime the system in order to get to it. The cold, so the essence of the whole thing is the release of endogenous opioids and cannabinoids from periaqueducal grade, which is related to stress-induced analgesia. So he hacks the system in order to release that. That creates euphoria. That it creates it decreases. Obviously you have the what is this? The posterior pathway, the pain pathway, which goes down back and the interneurons which blocks the pain reception. That's why you don't feel the pain. And actually that happens because it goes directly from the periaqueducal gray and nucleus solitary tract and parabrachial nucleus goes directly down and shortcuts it in here. So the signal of the pain and the cold not even comes to the central system. So that's actually the point.
At least as of now, in our work, we have no evidence that, in terms of a mechanism, that there is any cortical mediation of this. So his cortex was relatively silent in all of this. Except for the insular cortex.
Yes.
But the prefrontal cortex, the anterior cingulate, these really apex control regions of the brain, at least under the circumstances in which, and conditions under which we collected his data, which seemed to have much of a role.
And you said you did that with cold exposure with and without his breathing methods.
Yes. Correct. Now, there was a very interesting observation following his method. So the activation of periaqueductal gray that Otto is talking about is particularly salient after he does his method. But there were other physiological markers which were quite remarkable. The first day when he did cold exposure, of course we also collect skin temperature contemporaneously with fMRI signal and the application of the stimulus. And the skin temperature has a certain phase lag with the application of the stimulus itself. But it basically looks like, if you looked at the skin temperature curve, it looks like the water temperature curve, okay, except it's shifted in time. The first day, Wim's skin temperature curve was exactly like what you would expect. Okay. The remarkable thing about the second day was that, in fact, his skin temperature never changed from a basal state, even under the application of the cold stress.
Okay, you have to say that again now. Sorry.
So the second day, following his breathing technique and so on, his skin temperature never changed, even though we were inducing temperature-controlled water through the
See that?
So the skin temperature was straight.
But the hypothesis I thought was that he was able to control his skin temperature by first affecting his core temperature, which goes outward, which you would think there'd be some type of lag there. So you're saying just starting the cold stimulus.
No. So this is actually how it works. So he primes himself first. So he does his breathing and his breath retention, and then like after 10-15 minutes, it's okay, I'm ready. And then we do these things. So there is this.
So there's a priming there.
Well, you need the priming, yeah. So we didn't do it during the preparation.
Yeah, that's still impressive. Just after 15 minutes of that his skin temperature doesn't change.
That was very unusual.
That was very interesting, yeah. And again, so your point is well taken. That okay, Wim Hof is Wim Hof, and this is it's a freak of nature, and let's forget it. But it looks like he can teach it to other people, because you can see and people say, oh, it works. So I believe that they have some, definitely some release of opioids or calming or euphoria. So it looks like he can teach it to other people.
Yeah. In fact, there have been studies on people who have been taught to Wim Hof.
Yeah, so the big one is the one in Proceedings Natural Academy of Sciences, and that was the one that they took 12 or 30 people, and he taught them the method, and they showed that the pro-inflammatory markers were lower, the anti-inflammatory markers were higher.
That's actually interesting you mentioned, because I think this is a dead end. This is actually, it's going to turn out to be a dead end. Because if you're in a stress situation, it suppresses immune response.
Right.
That's actually the point. You're running away from the target. You have no time to worry about some bacteria in your thing. Not only does that, so you are full now of norepinephrine, cortisol, which we know it suppresses, immune reaction. But also, if you look, opioids do the same thing. Wow. So you release opioids that actually in the body they kind of release system. It also suppresses immune response.
Right.
So all these little things go into this immune response, but I don't think this is relevant at all. This is kind of an observation, which is nice, but why do you want to suppress your immune response? This only makes sense if you have, autoimmune disease.
Right. Well,
so you have Crohn's disease, okay, maybe that thing, but otherwise, for normal people, that makes no sense.
Well, it's interesting, though, because in the ICU, for example, if somebody has severe sepsis or septic shock, and they're fighting off an infection, they give steroids. And a part of that is to suppress the immune response, because some of the damage that happens when you have a severe infection is not the pathogen, It's the immune reaction to the pathogen.
Well,
and so there's this and autoimmune is something similar where the pathogen is very small, but you have an overreaction to the pathogen. In septic shock, the pathogen is MRSA or something.
I mean, people with rheumatoid arthritis, they should be doing Wim Hof method.
Well, so that's where I'm going to push back on this a little bit. So how relevant is this to treatment of chronic diseases, right? So they've shown these findings, and they've shown that through these techniques you can suppress the inflammatory cascade. But one interesting thing in the paper was that the effects are eliminated if they infuse bicarbonate to the subjects. So when you have hypercapnia, you have hyperventilation with hypocapnia. Right? Hypocapnia.
Low CO2.
Right. You in the acute phase, your bicarbonate's low, and they showed that the trained subjects had even lower bicarbonate. But as it becomes more of a chronic situation, your kidneys adapt, and they start increasing the amount of bicarbonate. Right. And they showed that if they infused bicarbonate, that the effects they showed were nullified.
But that's exactly what I'm saying, because then there is your oxygen saturation is not going to go down too much, because you see you are not going to be able to retain your breath for a long time. The only works if you have hypocapnia, your CO2 is really low, because now you can 90 seconds hold your breath because the body tries to move the pH value back up. But if this doesn't happen, you cannot, and your PSAT is not going down. That means your brainstem, your nucleus or solitary tract, your parabrachial nucleus, there's nothing happening. So why should they release norepinephrine?
But they're saying in the same condition, so hyperventilation with hypocapnia and low, after they hold their breath, low PO2, whatever's happening in that situation, whatever positive thing that's happening is eliminated if they infuse bicarbonate. And a chronic...
So PSAT, I think that the most, I think that what I think is crucial is the saturation of oxygen in blood. So whatever they say, because...
If that were true, bicarbonate wouldn't matter, though, right?
Well, but, it matters probably in the... But I don't know. But my view of this is that the only thing which all this breathing and thing does is eventually decreasing oxygen saturation in the blood, so that you get a stress reaction by your brainstem. That's actually what I'm saying, and might be true, might not be true.
Well, and the other thing I was thinking is, the pH of our blood is exquisitely maintained between 7.35 and 7.45 for a reason. All of the enzymes in our body are optimized at very slightly different pHs. So it's one thing to go for a couple hours and jack your pH up and have some kind of anomalous reaction to the stress response. But it seems to me a little bit short-sighted to think that, you just keep your pH at 7.69 for days and that's going to have no negative consequences.
No, I agree with you, but I think that what he does, that's actually a really, really great point. Let me answer that. I think what he does is only for the 10 minutes to prime the system. So now your system is primed. Now you hit it with cold. Now your periaqueductal gray. Okay. The oxygen goes back, but how he continues with the meditation, that's where the meditation comes in. And we know, placebo effect. Why do we have placebo effect? Because we know that there is some probably this is, I think it's a much weaker connection that your anterior prefrontal can directly, to a certain extent, influence maybe your periaqueductal gray through different routes, that some of the opioids are released. And that's actually what we call placebo effect. That you believe this is going to help you, then you will really feel better.
As kind of a side thing here. But
so that's actually how he continues. That's why he needs the meditation. That's why it's the third part. Mm-hmm. The meditation is sustained, because, you're right. You cannot, have your PSAT, 70%. This is just kind of kickstarted the whole system. Yeah. And once it kickstarted, and the thing, then he continues this with the meditation. Mm-hmm. That's actually how I think it works. So, and the point is that obviously the guy works on this for 15 years or 20 years, so he kind of perfected it. But after after what we're saying, you know, each of us could probably kind of say, okay, I kind of understand how this works. We could probably kind of duplicate it. And actually, next time you go out and you are cold, try to actually hyperventilate for 30 seconds. Mm-hmm. You will see that actually you feel better. I tried it several times. Yeah. It's actually really interesting.
Actually, I do this in the morning because
it's really interesting. Try it.
You do the cold showers in the morning? I know a lot of people are doing that.
Not immediately a cold shower, but following a warm shower, cold shower. But to prepare for that transition, I do try and control hyperventilation.
Yeah.
And not doing it versus doing it is a huge difference.
So there is something, and actually what I think is that, you know, we know that the breathing centers is the parabrachial nucleus of the solitary tract. They actually control cardiovascular and your respiratory. So again, it's actually really interesting, and you know, we speaking in this new paper is that usually when you get cold, it affects the parabrachial nucleus solitary tract, and they actually change in your cardiovascular, your respiratory pattern. Mm-hmm. He does exactly the opposite. He changes the respiratory pattern in order to change the perception. Huh. So instead of going from perception to changing your breathing rhythm, your respiration and cardiovascular, he goes the other way. And actually, that's what probably the monks and all these, you know, in
Tumo meditation
do. That they found a hack how you actually can influence your sensory perception by the breathing through the brain nuclei.
So that's what I was going to say.
That's actually, I think that's the added value. What actually, obviously he does what he does, but what we should start thinking about, that this is probably the mechanism.
It's not unusual that in Eastern traditions, these methods that monks use are almost always married to exposure to the elements. And so I think that's just not an accident.
Right. It's an adaptation or something, right?
I think
they figured out that
they figured it out.
Yeah.
They probably couldn't explain it, but I think, you know, over the centuries.
Right. Some lived, some died. The ones that lived taught whatever they're doing.
It's accumulated knowledge, and I think Wim would probably be the first person to agree that, you know, he's really leveraging accumulated knowledge.
Yeah.
Centuries.
So what did you guys think of Wim as a personality? I know he's kind of out there and all over the place, but he seems like a really interesting, fun guy.
He's an interesting person. He's definitely an interesting person, a little bit all over the place, but he's definitely, what I actually really appreciate about him, that he has kind of a missionary, feeling that he wants to really bring this under the people and help other people. Because he could say, hey, I'm okay. Obviously, it's a business too, so you know, like but I think he doesn't do it for the business. He does it because he really works it.
I think there's a sort of a messianic characteristic to him.
That's what I was going to ask, because that's very dangerous. I think for anybody, when you start to get into that realm of idolatry and people are coming to him now, is this almost, when you watch this Vice documentary, he's in the room, he's playing guitar, it's all dark, and they're all freaking out from hallucinating from their breathing techniques, and it's a little creepy. And when all these people are looking at you as their savior, and you're gonna cure my Crohn's disease, and I was wondering if that came through with the celebrity lately.
But the interesting thing about him is he has no affiliation with religion or religious thought.
But does he seem like a megalomaniac at all? Is that starting to creep in, or does he seem like a pretty reasonable guy?
I think my personal take of him was he's very infectious. His enthusiasm is very infectious. I think he, as Otto said, he really wants to know more about why is he doing what he's doing.
That's what I really expect.
I think he's a messianic kind of attitude. He wants
to change the world.
He
thinks that he can change the world. I think you would.
Yes. I think that he's really worried about other people and tries to do the best. So, but you know, it's actually really interesting what you're saying, because the ego is always part of it. I mean, that's for you when you see a patient, they're looking up to you, you help them, you feel good about them. Mm-hmm. And that's, I think, but I don't think that's a corollary to this, but I don't think that's the main part. I think that Wim, obviously his wife overdosed, it was a thing, he kind of had his own problem, he raised his children, 4 or 5 children, so he went through a difficult period, and probably this helped him. He kind of discovered it, hyperventilation when he swam in the cold river. He helped him, euphoria, didn't feel so bad, could be functional, could raise his children. And now he goes and say, you are depressed, I can help you. I went through that.
Right.
That's actually my take.
But unlike Godman, and coming from India, there are many instances of Godmen who are very attractive to Westerners.
Godman?
People who are gurus.
I gotcha, okay.
Wim doesn't have a overarching religious philosophy that he espouses. I think he's very narrowly focused on what it is that he can do, and he can do it demonstrably, and using that to help others. This is the impression that I had. Mm-hmm. He comes across as messianic because he's very, very animated, and I think what he does really, we think actually that what he does really alters mood in.
I'm sure.
I think that, and that's why I'm we didn't expect periaqueductal gray. Correct. Obviously, I not even thought about this. If you would have asked me before we did Wim Hof, that would be the last thing I would have told you. It was like complete surprise.
So that was a big surprise.
It was like, but the effect is so strong. It's not like you see something and who knows and you misinterpret. It's like this is it. It's very clear.
And you attribute that to what again?
To the stress-induced analgesia. So there are stress-induced analgesia again. You run away from, you're stressed out. You run away from a tiger. Something happens. Or the berserkers. Why do the berserkers? You cut off their hand. They not even stop.
Right.
Because they are euphoric and they don't feel pain. And there is a certain mechanism in your body that provides it.
Right.
And the mechanism works that periaqueductal gray, which is a center of pain center, releases opioids and cannabinoids, which then work together. They have a little bit different functions, but they work together in order to promote exactly stress-induced analgesia. And now we can talk about stress-induced analgesia.
An interesting ancillary question is going to be, and that's what we're going to be interested in, is how does this change psychiatric states? Like mood, for example. So one of the things you probably noticed in the Vice documentary was really extreme feelings of euphoria in people who are practicing the method. /
hallucinations.
Yeah. And that's not accidental.
Yeah.
I think it's clearly physiological.
Right.
And so the question is, what are the implications of that for psychiatric conditions? Because those are very open questions. Really
bipolar disorder.
Well, I just heard an interview. Have you guys ever heard of Rhonda Patrick?
No.
She's a biochemist, and she makes the rounds in different podcasts I listen to. But she was just in Amsterdam, and she was saying that she was at the Van Gogh Museum, and she was reading about Van Gogh. Right, sorry.
Which, when you say in America, people think you don't know anything about.
See, but if I would have said that Van Gogh, it would have sounded so pretentious that. But the treatment for him back in the day was ice baths for his depression, and that was something they did in the Netherlands all the time. And it's just funny when you go back in history and you see that somebody thought there was something up with that way back then, and then it comes back.
We've had psychiatrists tell us anecdotally that many of their patients with depression or mood disorders always feel cold. They feel like that they're in a state of unbalance in terms of sort of where they are in, how they feel, from a thermoregulatory standpoint. But if you think of it, a frontline treatment for depression and mood disorders, serotonin, SSRIs, serotonin is implicated in thermoregulation.
Is it?
And SSRIs are actually used as an experimental treatment for highly symptomatic menopausal women as well.
But you see, I think this is an important point. Drugs, which you give external drugs, is systemic, and that's actually the problem. This is the problem, systemic drugs, because it's like filling your gas tank in a car 100 feet above. Maybe you get a little bit in your tank, but most of it goes in your seats. That thing unfocused. It screws you up in a lot of things.
You're saying it doesn't get to the blood-brain barrier to where it's needed? Or? That's
the thing. That's the problem, that you want something natural, which is, you see, if we could get, the point is, either nanotechnology or whatever, micro-injection into your brain to specific nuclei of the brain release. If we could do that, forget Wim Hof. We don't need that. But short of that, we cannot do it right now. So right now,
What about transcranial electrical stimulation? Have you guys looked into that at all?
I looked a little bit into it because we used this in epilepsy. I mean, we kind of messed around with it. It's, definitely works. The problem is that you cannot go very deep into the brain. It's more cortical, because of the scalp, because of a lot of things. But, that's actually really interesting also because in psychiatric diseases, people try the frontal lobe and try to affect by frontal lobe suppression what's going to happen then in other parts of the brain.
Right.
So I think it's kind of a side issue.
So there are two applications which are quite interesting. One is in treatment-resistant depression.
Yeah.
So essentially directly stimulating subgenual prefrontal cortex. And there is some evidence that in some cases of highly refractory treatment-resistant depression, that does work. And the other case that, to my knowledge from personal experience, because my mother has Parkinson's, we've discussed this, is implants into subthalamic nuclei.
That's pretty deep. Yeah. Implants into the thalamus?
Yeah, and the impression that I've been given is that those are, at worst, they have no effect. But at best, they have.
I guess you're comparing that to a lobotomy or some of the things I used to do.
Exactly.
Still pretty semi-non-invasive.
Yeah. No, but I think that the point we try to make is that right now, when you give systemic drugs, they have a lot of side effects. And what we call side effects is really all these things that's good in one part and in 20 other parts interesting. And that's what's called side effects. So if you can, and what we call natural is when you have it more focused. So microinjection and transcranial stimulation. I mean, have you ever seen how it's done? I mean, people map out, the thing, what is the maximum of the, motor cortex, and then because nobody knows what to simulate, then they put it somewhere. It's a mess. I mean, it's like when people did surgery in the 1850s. When you say, "Man, I can't believe anybody survived how they did it." This is amazing.
They still have some of those instruments at Wayne State that you can see.
Exactly.
It's like I can't believe this actually worked. It was worth the effort. Probably leave the guy alone. So that's actually how we're gonna look back on this transcranial stimulation. People tried the best, but this was pretty rude.
But that's what makes Wim Hof method and methods like that, or yoga, for example, which apparently is quite well indicated for depression now.
Sure.
It makes them so compelling because I think these are lifestyle hacks.
And actually, he's very motivated in. That's actually when he started. He said, "Oh, we need to the depressed people." For whatever reason, depression is a big issue to him. Maybe
we know what reason.
But
what happened to his wife is so traumatic.
So because he said it at the beginning, I really want the depressed people. He's not that interested in kind of normal people. I think that he pursues this, this camp in Poland, the Snezhka, they have the hall where, rich people go and then they run around. In short, it's kind of nice, you make some money, but I don't think he sees this as necessarily his calling. I think he wants to really get into helping really depressed people.
Well, that's great. Well, I know you got a hockey game with your daughter? Soccer. So
football.
You're both going.
I'm going to.
Do you want to go?
No, I can't. But is your daughter playing or is it?
No. This is. Have you heard of Detroit Football Club? That's the club that plays in Hamtramck at the stadium.
Okay.
It's sort of a small, semi-professional football club, soccer club.
Okay.
And they have a very loyal fan base. I'm not part of the fan base, but the fan base actually renovated this historic stadium. They painted the bleachers themselves. They rebuilt them.
Cool.
And so today is their home opener.
And I'm guessing your daughter plays soccer.
She plays soccer.
And Otto, do you have kids?
I don't have kids now.
No.
But I play.
But you like soccer?
Are you kidding? I was a big star.
Otto seems like he'd be tenacious defender.
No, I was a forward. I was really a very, very fast player. I was like Messi. And my wife calls me Messi with a Y.
Well, I just want to thank you guys so much for doing this. You guys are actually the first podcast. I didn't want to say that. I thought maybe you get scared off you wouldn't do it if I told you that.
No. This is the beginning of big career. You will see in 20 years, now I'm established and rich and made my living. And these were my first people. Historic.
That's right.
Years, when the Wim Hof method is established as a cure-all for everything, you can say it all started with
That's right. It's all because of us. Well, I can honestly say that I would have done this regardless of all this podcast stuff, and it was really fun to talk to you guys, and I wish you the best, and I'll keep in touch with you guys.
By all means. Wim will be
Thank you very much.
Great to meet you guys.
It was fun talking to you.
Have fun at the soccer game.
We will.
Excellent.
All right, guys.
All right.
So, first one in the books. Thanks so much for listening. And like I said, I know that was kind of hard to follow, but I'll get better at kind of structuring these conversations going forward. The next one is with Mark Lumley, who's a psychologist at Wayne State. And we're going to be talking about mindfulness and non-traditional ways of managing chronic pain. So until the next one, swing easy.